Good day everyone, I am Eugene Solis and I am going to discuss the geotechnical engineering in ULO 3. So what is geotechnical engineering is? So geotechnical engineering is the subdiscipline of civil engineering that involves the natural materials found closest to the surface of the earth such as the rock, soil and the water. So geotechnical is also one of the branch of civil engineering to study the natural material. So geotechnical engineering is the application of the principles of the soil mechanics and rock mechanics to the design of foundations, retaining structures and earth structures. So what do engineers do? Geotechnical engineering, evaluating of geotechnical hazards including the potential of landslide, also determining of bearing capacity, deformations of foundations, and likely interaction between the soil, foundation and earth structure. Also assessment of the earth pressure and the performance of retaining walls. So they are also responsible for the assessment of performance of the retaining walls, analyzing of embankment behavior, the rivers, strength of excavations, caves and tunnels, conducting of response analysis for a site. So geotechnical applications. One of these is the foundation. Foundation is the lowest load part of the building, typically found to the ground level. So there are two types of foundation: the shallow foundation and deep foundation. Here's the example of the shallow foundation and the deep foundations. As you can see, the difference of the two. Actually, as I've researched, the shallow foundation is only 1.5 meter deep, and the deep foundation is approximately 10 feet deep of foundation. Also, geotechnical applications, underground and earth retaining structures. One of these is the tunnel and the retaining walls. So the train release and the walls. Also excavations. So when constructor are planning to build infrastructures, they are going to do first digging a deep hole. Also the embankments, the river. One of the example of this is the Pasig River. Also dams. As I've said, the geotechnical engineering is the study of natural materials such as the water, rocks and the soil. Earthworks. Geotechnical engineering are responsible for the investigating and monitor subsurface of conditions and superficial materials at a site, ascertain the relevant geotechnical properties of site materials. They also evaluate and monitoring the geotechnical integrity of man-made and natural soil, rock, slopes and deposits. Assess and monitor risks associated with the site conditions. Carry out earthwork and structure foundation designs and monitor the geotechnical performance of these designs. And lastly, the prescribed ground improvements to enhance the geotechnical integrity of a site. As a geotechnical engineering needs to an interest in the natural world, practical and technical skills, a problem solver, planning and organizational skills, strong written and oral communication skills, and the ability to work independently or as a part of team. In historical developments, the ancient Greek civilization used to isolated pad footings and strip and rock foundation for building structures. So here's the example of the pad footings and the strip and rock foundation. Dikes were built during Indus and Chinese civilization around 2000 BC. Beginning around 2700 BC, several pyramids were built in Egypt. Geotechnical engineering prior to 18th century. So, to Charles Coulomb, 1736 to 1806, he is a French engineer who published the wedge theory of earth pressure in 1776. This is the first major contribution to the scientific study of soil behavior. Now, the modern day, Carl Terzaghi, 1883 to 1963, he is the father of the soil mechanics, who developed the theory of consolidation for clays. The consolidation of theory was published in his book Erda Biomechanic in 1925. Arthur Casagrande in 1902 to 1981, known for his ingenious designs for soil testing and apparatus and research on seepage and soil liquefaction. Rob Peck on 1912 to 2008. He was an eminent civil engineer specializing in soil mechanics. Also, he was a National Medal of Science in 1975 for his development of the science and arts subsurface engineering, combining the contributions of the science of geology and soil mechanics with practical art of foundation designs. And that's all. Thank you.